This video I'm going to go through our test review for Chapter 1 in Algebra 1. So we're going to start off here with some pretty basic equations. I guess I should say first, I'm hoping that we're using this to check our work. Remember, this should be used as a tool to kind of help you get along. If you just watch and listen and don't do any problems on your own, you're not going to pick it up. You got to make sure you can do problems like this on your own, and there should be plenty of resources available to you. So these first few equations, we're just going to be kind of thinking about order of operations here, how we get the variable by itself, and some different methods we need to use and different things we need to think about. So number one, I've got 4.2 equals 0.6x. So x is my variable I'm trying to get by itself. And the thing that I need to remember in this case is that 0.6x means there's multiplication there. We don't see it, but that means 0.6 times x. And so we always want to get rid of those. I say I want to get rid of this 0.6 and leave myself with just x. I do that by using inverse operations. So since that's being multiplied by x, I would divide by 0.6. And whatever I do to one side of the equation, I have to do to the other. And so that's going to turn into 1 and basically go away. I'll be left with just x on the right side of the equation. And on the left, I just have to divide 4.2 by 0.6. 4.2 divided by 0.6, and you should get 7. Traditionally, we write our answer in the other way, where I've got my variable first. So in the future, I will probably just do that without making it an extra step. Moving on to number 2, this is a two-step equation. Now I've got to do two things before I can get that x by itself. I always think of it like this. I have to get rid of this negative 12, and I have to get rid of that 4. And when I do, I'll be left with just x. So we always want to do this first, so I'm going to do the opposite here. Right now I've got minus 12, so if I add 12, that's going to make that 12 go away. If I do it to one side of the equation, I have to do it to the other side of the equation. So on the left, 34 plus 12 is 46. On the right, I've just got 4x. So now, again, I've got this 4x, and we have to remember that means 4 times x. And so in order to undo that, I'm going to divide by 4. What I do to one side of the equation, I have to do to the other side of the equation. And 46 divided by 4 is 11.5. So x equals 11.5. And remember, you can always check your work by plugging that answer back in. So in other words, since I'm saying x is 11.5, I could just do 4 times 11.5 minus 12, and I should get 34. So that's how we check our work. Moving on. Number 3, now we're getting to a place where we have to do some distribution and some combining like terms. So remember, when we have this notation here, where we have the parentheses and a number outside, that tells us we need to distribute. So that's multiplying negative 6 times x and negative 6 times 3. So we would end up with plus a negative 18 here. I'm just going to write that as minus 18, because that really means the same thing. And then I've got minus 12 equals 126. I can combine a couple terms here, because these are just numbers. So negative 18 minus 12 is going to give me negative 30. Negative 6 minus 30 equals 126. And then we're just back to a two-step equation. Add 30 to both sides. You get 6x equals 156. And then divide by 6. And 156 divided by 6, you should get x equals 26. Moving on, we've got some absolute value. So remember, when we have an equation like this, we want to first get it down to where it's just an absolute value. And then as long as it's equal to a positive number, we can split it into two equations, because absolute value always has to equal a positive number. So in order to get it down to just the absolute value, I'm going to subtract 7 from both sides. So I've got absolute value of 3x plus 4 equals 6. 13 minus 7 is 6. Now that we've got it here, we can split this equation into two, and I'm going to be a little bit short on space here. Let me see if I can kind of fit them over here. So we've got 3x plus 4 equals positive 6, or 3x plus 4 equals negative 6. And we'll solve these two equations, and we should get two different solutions, and both of them will make this equation true. So subtract 4 from both sides. We end up with 3x equals 2, divide by 3, and x is equal to 2/3. So that is one solution. And it's going to end up being the same exact process over here, subtracting 4 from both sides. 3x equals negative 10. And when we divide both sides by 3, you should get x equals negative 10 over 3. And we can leave our answer just like that. Or you could punch it into a calculator and get a decimal if you wanted. All right, moving on. Determine whether the equation has one solution, no solutions, or infinitely many. So we'll go ahead and we'll solve through this, and then we will talk really briefly about what it looks like to have this different number of solutions. We first need to do our distribution. Okay, we can distribute, so I'm going to do that first. I'm going to do that on both sides and just kind of simplify things down here. So I have negative 3x minus 9 plus 5 minus 2x equals negative 4x plus 20 minus x. And I have a whole lot of combining like terms. Remember, that only works when it's on the same side of the equation. So I can combine stuff over here and I can combine stuff over here. Anything with an x value, I can combine. And then anything with numbers, I can combine. So I've got negative 3x and negative 2x. That makes negative 5x. I've got a negative 5 and a negative 9 and a positive 5. That makes negative 4. On the right side, I've got negative 5x plus 20. So I'm going to go through my solving process. I've got variables on both sides. I always want to get all the variables to one side. I'm going to add 5x to both sides here. And notice what happens when we do that. Both of those terms are going to go away, and I'm going to be left with negative 4 equals 20. And so this is one of those situations where there are actually no solutions to this equation, and we know that because of what we ended up with. So when all of the variables go away and we end up with a statement like this that is untrue, it is not true that negative 4 equals 20, that tells us that there are no solutions. If our variables go away and we end up with something that is true, so for example, you might end up with something like 3 equals 3, that would tell us that there are infinitely many solutions. And then what we normally see is that one solution case where we get x equals a specific number. All right, moving on. Number 6, you solved the following equation and found the solution of x equals 9. Check your solution and determine if 9 is a possible solution to this equation. So remember, when we check our solution, we take that x value and we plug it in to our equation wherever there is an x, and we see if it gives us a true statement. So if it gives us an untrue statement, then that is not a solution to our equation. So I'm just going to copy this down exactly like it is, but instead of x, I'm going to put 9. And let's see what we get. So I can simplify here. 1/3 times 9. If we remember fractions, I'll just kind of do this on the sidebar here. 1/3 times 9 is like 9 over 1. When we multiply fractions, we multiply straight across. So this is 9 over 3. And that's just division, right? Fractions are the same as division. 9 divided by 3 is 3. So we end up with 3 minus 13, absolute value, equals 90 divided by 9 is 10. So let's do this inside the absolute value. 3 minus 13 is negative 10. So is it true that the absolute value of negative 10 is equal to positive 10? Yes. Okay, so we would say yes, 9 is a solution. Moving on to number 7, the second problem like this. This is the same idea. Okay, just give you an extra opportunity to practice this. Take that x value, we're going to plug it in to both places. There's an x. So I've got 1/4 times negative 12 plus 8 equals negative 12 over 6. And I don't need to go any further than this. I can see right away that this is not going to be a possible solution. And the reason is I have a negative number over here. Negative 12 over 6 is going to be negative 2. And I have an absolute value over here. So the absolute value of anything has to be a positive number. So when it equals a negative number, I automatically know that this has no solutions, right? The absolute value can never equal a negative number. Number 8, we have a proportion. And so I've got x over 3. I want to get x by itself. So doing the inverse operation, we are just going to multiply both sides by 3. So let me just rewrite this so it's easier to show my work here. So I'm undoing this division by multiplying by 3, and that's really like 3 over 1. Okay, that always helps me when I'm multiplying fractions, and remember, we multiply them straight across. So on the left, 3 times 64 and 1 times 8. 3 times 64 is 192 over 8. And on the right, the whole reason we did this is because that's going to give us just x, right? This is going to be x, 3x on top, and then just 3 on the bottom. That leaves us with just x. And we can simplify that fraction. 192 divided by 8 is actually 24. So x equals 24. The other type of problem you might see, remember, is where the variable's on the bottom. And we can just flip both equations. So for example, if this was 8 over 64 equals 3 over x, notice that all I've done is I've flipped both of them. These work the same way. So if I had a variable on the bottom, I would want to just flip both sides of the equation, make it like this, and then it's just a one-step problem to get x by itself. Number 8, car A traveled 178 miles in 2.75 hours. Car B traveled 220 miles in 2.9 hours. Which had the greater speed in miles per hour? So we're looking for how many miles per hour. That's a rate. And so for car A, we have 178 miles per 2.75 hours. And then that's just division, right? All we need to do is do the division and we will get the rate in miles per hour. So 178 divided by 2.75, and you get 64.7 miles per hour. And then for car B, we've got 220 in 2.9 hours. So again, let's just do our division. And we end up with 75.8 miles per hour. If we're rounding, this should technically be 75.9. So this tells me that car B had a higher rate in miles per hour. All right, moving on. We have some equations here where we've got more than one variable and we're trying to solve for a specific one. So this says solve for x, so I'm trying to get x by itself. And the thing to remember with these equations is we're going to treat everything just like numbers. Our solutions might end up looking a little bit messier, but it's always the same process. All right, if I'm trying to get x by itself, that means I need to get rid of everything else on that side. I need to get rid of this negative 3y, and I need to get rid of this 5, and it's the same way that we do it with anything else. So since this is a minus 3y, I'm going to add 3y to both sides of my equation. And when I do, that's going to give me 5x equals 4 plus 3y. The only thing that's different is I can't combine these terms now. It just has to stay like this. And then 5x means 5 times x, divide by 5, and we get our final answer. X equals 4 plus 3y divided by 5. And that's it. It just has to stay like that. Number 11 is just a little bit different. I'm trying to get m by itself, but I have two m's on the same side. So I've got mx plus mb. When you have this situation, where you've got the variable that you need on the same side, separated by addition or subtraction, this is where we need to factor. So I need to divide out my m from each of these terms, and that would look like this. I'd have my m, and then in the parentheses, whatever's left over. So I would have the x and the b left over. And now, this is just one-step equation. Since I've just got multiplication, I'm just going to undo that by dividing. Divide by x plus b. And that's it. M is going to be equal to y over x plus b. All right, final question. At a restaurant, you buy 3 sandwiches and an ice cream. The cost of the ice cream is $2.75, and you spent a total of $13.25. So we need to set up an equation. We've got a couple questions down below, but I'm just going to try to set something up first just to understand what's going on. And this is what you're always going to want to do with these types of problems. Just set up an equation to help you figure out what is going on. How can we represent this situation? If I'm buying multiple of something, so if I'm buying 3 sandwiches, right, if they cost $5 each, I would just take 5 times 3. So however many times I'm buying that. Same with ice cream. We're only buying 1, so it's just going to be 1 times $2.75. So here's what I know. And I'm just going to pick my variables because I can choose anything I want. I'm going to try to pick something that makes sense. So I'm buying 3 sandwiches. I'm just going to choose S for sandwiches. And 1 ice cream, so plus 1 I for ice cream. And I could put a 1 in front of it, but I don't need to because it's a 1. And I know when I do that, I'm going to get my total amount. Right? So if I'm buying 3 sandwiches, I'm going to multiply 3 times whatever a sandwich costs. And then I'm going to add to that 1 times however much the ice cream costs. And when I do that, I'm going to get my total amount. Part A says, how much did you pay for 1 sandwich? So in other words, I'm trying to figure out what this value is right here because S represents the price of a sandwich. So let's start plugging in some numbers here. It said an ice cream is $2.75, so that's what my I is going to be. My total is $13.25. That's going to go here. And once I plug those numbers in, it's going to be really easy to get this S value by itself. So 3S plus 275 equals 1325. And this might be a good place to kind of pause and try to digest all this if it's not making sense, and then come back after a minute for the solution part. So once we've got it here, we've got a basic equation just like we've already solved a whole bunch of times. Minus 275 from both sides. So 1325 minus 275 is 1050. So I've got 3S equals 10.5. Be careful that you don't mistake your S for a 5. It's the one issue with using that letter. Now, all I need to do is divide by 3. Divide both sides by 3, and I will get my price of a sandwich. S equals 3.5. Or we could say the price of a sandwich is $3.50. Moving on. What would your total cost be if you bought 5 sandwiches and 3 ice creams? Now, we can kind of go back to our original equation. We already laid out how all of this stuff is connected. And now I know the value of S, and I know the value of I. So 5 sandwiches, so I have 5, oh, this is going to get really confusing because I've got a 5S, so 5S plus 3I equals my total. If sandwiches are $3.50, that means I've got 5 times $3.50, and I want 3 ice creams, and they are $2.75 a piece. And what I want to know is my total. So just punch this into a calculator. 5 times 3.5 plus 3 times 2.75, and you get your total of $25.75. And this would work the same way if you're talking about like doing a job and you get paid X amount per hour. All of that is just multiplying. So like number of sandwiches times how much they cost. Number of hours worked times the amount you get paid per hour. And then usually you're going to have 2 different things that you need to then add together to get a total cost or a total amount of money made.